Average atomic mass. So we are going to learn what is the average atomic mass in this video. So average atomic mass is the average of an element's isotope mass. So in the last video we learned about isotope, and we know that in nature we might have different isotope of the same element. So when we are talking about the mass of isotope, mass of an element, we don't know which of these isotope we are talking about. So therefore, we have to find an average of all of these isotopes, and that's what we call average mass, atomic average mass. So before we move on, let's read some of the definitions. So the first one is atomic mass. Remember in the last video we talked about atomic number. So do not mix up these definitions. Atomic number and mass numbers are whole numbers. We cannot have, 12.5, for example, for atomic number. Atomic number and atomic number and mass numbers are whole numbers, and these two tells us the number of protons and number of neutrons. So we cannot have, like, for example, two and a half protons, right? So you have 2 protons or 3 protons. Atomic mass is the mass of the atom in atomic mass units, AMU. And what is atomic mass unit? Well, the atomic mass unit is a mass of exactly equal to 1/12 of mass of 1 carbon-12. So if I show carbon-12 atom as this, so take it as carbon-12 from me, okay? So if I divide this to 12 pieces, 12 equal, and let's take it as equal, I think it was 12, I don't know. So if they're 12, so just one piece of that, just like a piece of pizza, so just one slice of this carbon-12 is 1 AMU. So they had a carbon-12, they divided by 12, so just one piece of that, the mass of one piece of that is 1 AMU. And that's just basic of this measurement, okay? You might ask, why carbon-12? They had some reasons, but we're not going through the reasons why. But just take it as the basics for finding the AMU, defining the AMU unit. They used carbon-12, and they used 1/12 of that carbon-12. So 1/12 of that is 1 AMU. We talked about isomers and atomic number, mass numbers in the previous video. So carbon-12, this 12, if you remember, it tells us the mass number, right? So if you have carbon-12, think about it for a moment and tell me which of these 3 carbon-12 made up of. So hopefully you choose A, and that's the right answer. So we know it's carbon-12, so this is proton and neutron, and if you check the periodic table, you see that the atomic number for carbon is 6, so it has 6 proton, and it should have 6 neutron to make 12 atomic number. And it's neutral, no charge, so it's 6 proton, 6 neutron, and 6 electron. So if you go back and look at a definition of AMU, we just said that AMU is 1/12 of mass of carbon-12. So with that definition, what is the mass of one atom of carbon-12? It shouldn't be a hard answer. Just think about it and choose one of them. So hopefully you choose 12, option C. So if 1/12 of that is 1 AMU, the whole carbon-12, if you remember, I just drawing lines, I don't know if it's 12, but one slice was 1 AMU, and we have 12 of that, so that makes it 12. And it should be exactly 12, right? Because that's the basis of defining the AMU. So 12 of this 1 AMU unit is 12.00, and I can put as many zeros as I want because it's an exact number. So the mass of carbon-12 is 12 AMU. If you check the periodic table, what atomic mass do you see for carbon? Well, if you check the periodic table, you will see that the atomic mass is 12.01. Then that's one of the numbers you see in the periodic table. If you look at each element, it gives you the atomic number, atomic mass. So you can see these numbers in the periodic table. So you see the atomic mass of carbon as 12.01, but we just said that the mass of carbon-12 is exactly 12.00 and many zeros. So why is it not 12.00? Why is it 12.01? It's because the mass that you see in the periodic table is the average mass of carbon, and it's a weighted average. So if you think about it, carbon has carbon-12 and carbon-13. We talked about isotopes. Well, we do have carbon-14, but it's not that much and it's radioactive. So the isotope that we can find from carbon is carbon-12 and carbon-13. And the abundance of carbon-12 is much more than carbon-13. So that's why we say it's weighted average. So if you want to take average, if you just have these two, well, basically you have to add 12 and 13 and divide it by 2, right? That would give you 12.5, but that's not how it works. So the average atomic mass is the weighted average. So the good example for the weighted average is how you can find your final grade for this course. And you see that the exams and the finals have the most part of the final grade. So let's say if you get A on the exams and the final, but you don't do good on the homework or recitation or anything, you still are going to get A or maybe B. It depends, okay? Because that part of the grade has more weight on it, okay? It's heavy weighted. That's the same thing with the average atomic mass. So most of the carbon that we find in nature is carbon-12. So the average atomic mass is very close to 12. We have some carbon-13 that has the mass of 13 point something, but the average mass is very close to carbon-12 because we have more carbon-12 in the nature. And the percent that we find the element in the nature is called natural abundance. So natural abundance is the percent of the isotope that we find naturally on the planet Earth. So here we have the numbers. So as I said, we have most of the carbon that you find in the nature as carbon-12. And I said most of, but we can see the number here. So 98.90% of the carbon is carbon-12, and we have 1.10% of it as carbon-13. So how can we find the weighted average of these two? Well, let's write down the formula. I feel more comfortable with the mathematical language. So if we call the average mass as M, it's x1 m1 plus x2 m2, and that's will continue if we have more isomers. It means we have x3 m3 x4, and we can continue. But for this course, you don't have anything more than 2 isomers, okay? And this M is the average mass. X is natural abundance and I just defined what is natural abundance. Uh, it's how often you find one isotope naturally in the planet Earth. Okay, and M1 is the mass of isotope. Okay, so we have the mass of isotope. This is the mass of carbon-12 isotope, and this is the mass of carbon-13 isotope. And we have the natural abundance. One thing you have to remember, natural abundance, usually we report natural abundance in a percentage form or in a ratio form. But the one that you have to use in this formula should be in ratio form. How can we get that? So, for example, for carbon-12, the natural abundance is 98.90%. So if you want to write this in a ratio form, it is 0.9890. So as you can see, I just moved the decimal place to the left, 2 digits to the left. And the ratio form cannot be anything more than 1. It's something between 0 to 1. So that's the ratio forms, and that's what we use. So to find the average mass for carbon, we multiply the natural abundance in a ratio form, which is 0.9890 times the mass of that isotope, and we are talking about carbon-12, so it's 12.0000, and I can put more zeros if I want to, it's the exact number, plus you add this value to natural abundance of the second isotope. Now, how do we write the ratio form for 1.10%? Well, we move 2 decimal places, so it's 0.110 times the mass of our second isotope, which is 13.00335 AMU. And that will be 12.01, exactly as we saw in the previous slide. So that's how you can find the average mass. So if you see the average mass and you have 2 isotopes, so you can find the average mass in the periodic table. You cannot find how many isotopes of that element you have. But if I tell you some element, I don't want to write a symbol, just an imaginary element. If it has, I don't know, 34 and 35, and the average mass is 34.2, okay? Can you tell me which of these 2 isotopes we have more, or which of these 2 have a higher natural abundance in planet Earth? Well, you have to see the average mass is close to which of these 2. So it's 0.2, so it's more close to this one. Therefore, the first isotope, isotope 1, and this one is 2, isotope 2, so it's more close to the isotope 1, so we have natural abundance higher in the first isotope. Okay, so we're going to have more examples in the recitation on average mass, so you feel more comfortable about it in the exam. And also you can you can also find the end of chapter practice to work more on this concept.